Texas Instruments Innovation Challenge India Design Contest 2015 CMTID 222. Project title Automated Irrigation System by Lokesh T. Manigandanji, Department of Information Technology. Mentor Mrs. S.A. Angerkani, Assistant Professor, Department of Information Technology, RMK Engineering College. Agriculture uses 85% of available freshwater resources worldwide, and this percentage will continue to be dominant in water consumption because of population growth and increased food demand. In India, agriculture has a significant history. Today, India ranks second worldwide in the farm output. The economic contribution of agriculture to India's GDP is steadily declining with the country's broad-based economic growth. Hence, we feel automation for water irrigation is a vehicle to improve the lifestyle of farmers and improve irrigation efficiency at the farm level. Automatic irrigation will improve water use efficiency by providing an accurate cutoff of water going on to fields during irrigation. This ensures that irrigation is more efficient, reduces waterlogging of plants, reduces groundwater accessions, and reduces the risk of excess water running off the field. Welcome to our working module session. Initially, all the components are interfaced and are placed in appropriate positions as given in the block diagram. Power source is applied to the Stellaris launchpad. As a result, it processes the source code, simultaneously receiving the signals from the other sensors. Here, the calendar clock is checked for the threshold, where the threshold value is already set for each sensor. If the red value from the sensor is less than the threshold value, watering is done until the condition becomes false. If the red value from the sensor is greater than the threshold value, then watering is stopped. Now let us see the overview of our project. The board at the bottom is the Stellaris launchpad, and the board that is fixed above it is the Boost XL sensor. Boost XL sensor consists of many sensors. Some of them are here. This is the humidity sensor, and here comes the temperature sensor, and here is the pressure sensor. We also have a moisture sensor that is dipped into the soil, and this is the solenoid valve. We have interfaced both moisture sensor and solenoid valve into our Stellaris launchpad, and now we are going to embed our source program into the Stellaris launchpad. This is our source program. Now we're going to build it. After building, we must do debugging. We know that before debugging, our Stellaris launchpad is in hibernation mode, and at once debugging is finished, it will change into a constant glow mode. See, it's here. This change in glowing is due to the red value less than the threshold value that is being fixed. Now the LED changes from the hibernation mode to constant glow mode. This change is due to the red value from the sensor as being less than the threshold value fixed to it. Now we are going to add some water into the soil. And because of this, the red value from the sensor is greater than the threshold, and so the LED goes back to the hibernation mode. A moisture sensor is associated with Stellaris launchpad. Each subsensor is periodically interrogated by a pulse signal provided by the microcontroller via a driver or buffer circuit. This interrogation signal causes the moisture sensors to output an analog voltage which is proportional to the amount of moisture in the soil in which the sensors are embedded. The moisture sensors then respond by transmitting the before mentioned electrical signals to the microcontroller. Thus, the microcontroller activates each of the valves on a given watering day for a predetermined watering interval beginning with a pre-programmed start time and lasting for a pre-programmed interval. Most products operate between 20 and 40 pounds of pressure. The soil type will dictate how a regular drip of water on one spot will spread. And in case of elevation, variations in elevation can cause a change in water pressure within the system. Pressure compensating emitters are designed to work in areas with large changes in elevation. We would like to thank our mentor, Mrs. S.A. Angyakarni, and other professors who helped us throughout this project. And we also wish to thank Texas Instruments as they have provided a platform for us to showcase our talents. And once again, thank you.